In this video, we're going to look at part 2 of the section on, we're remind you that we're looking at ways to look at the performance of asset managers. Part 1, we looked at the dollar-weighted rate of return. So now we're going to look at the time-weighted rate of return as a way to measure the performance of an asset manager. Let's look at the example. This is going to be very similar to the example where we did the time-weighted rate of return. All of the numbers are exactly the same. I just need a little bit more information. So on January 1st, I got an investment account balance of $100,000. On December 31st, the balance is $96,000. On April 1st, I have a $50,000 withdrawal. On July 1st, I have a $50,000 deposit. That's all the same information that I had on the example where we did the dollar-weighted rate of return example or lesson. But now I need extra information here. I need to know some information about how much was in the account on these dates. So I've added this column, this last column. The balance before the transaction was $105,000 on April 1st and $75,000 on July 1st. And we want to determine the asset manager's performance using a time-weighted rate of return. So next slide, I just want to show you the dollar-weighted rate of return example that we did on that lesson. And just to try to convince you, we're looking at the same numbers. I just have to throw in some extra information about what the balances are at the times of those transactions. Okay, so in the video on dollar-weighted rate of return, I captured all of this information in a timeline. So this is what the timeline looked like with the dollar-weighted rate of return example. Same information, but I've got this the extra information now with the balances before the transaction. So let me put that information in. So the balance at time 0.25 before the transaction is $105,000. The balance at time 0.5 before the transaction is $75,000. So again, let me move the timeline up to the top of the screen so I get more room to work with. So since the balance before the transaction at time 0.25 was $105,000, at time 0.25, the transaction was a negative 50, a withdrawal from the account of $50,000. So that's going to leave a balance after the transaction of $55,000. Likewise, the balance after the transaction at time 0.5 is going to be the $75,000 plus the $50,000 or $125,000. Okay, so now I've captured all this information in a timeline. I've got it all ready for me for me to proceed. So let's look at the idea behind the time-weighted rate of return. This is going to be a compound interest rate, which is determined by subtracting 1 from the annual accumulation factor. Of course, the annual accumulation factor I'm thinking of as 1 plus I, so I subtract 1 to get the I. That's the time-weighted rate of return. And as before, the annual accumulation factor is the product of the relevant periodic accumulation factors. Okay, so let's look at how we would proceed with this example. So as before, I'm going to simplify the notation. Instead of using an I with a subscript of cap T, cap W for time weighted, I'm just going to use an I. So 1 plus I is the annual accumulation factor. And again, this I that I'm going to be calculating here will be a time weighted, the way I calculate the time weighted rate of return. Okay, so the relevant periods then go from time 0 to time 0.25, from time 0.25 to time 0.5, and then from time 0.5 to 1. Those are where the transactions are occurring, so that's the relevant time periods. And so the annual accumulation factor I can think of as the periodic accumulation factor from time 0 to time 0.25 times the periodic accumulation factor from time 0.25 to 0.5, and then times the periodic accumulation factor from time 0.5 to 1. Okay, so now let's look at how we calculate these things. Between the time 0 and 0.25, well, in between those two times, I've highlighted in red what happened. The 100,000 accumulated to 105,000. So the periodic accumulation factor from time 0 to time 0.25 would be the 105,000 divided by 100,000. Likewise, between times 0.25 and 0.5, 55,000 accumulated to 75,000, so that corresponding periodic accumulation factor would be 75,000 divided by 55,000. And then between time 0.5 and 1, 125,000 accumulated to 96,000. That's not a very good performance, but so be it. The periodic accumulation factor then would be 96,000 divided by 125,000. Take all of this product, take the product of these three factors, and then subtract 1 to get what the I value would be, and you'll see that I is a 0.09 9.96. So about a 9.96% return. So that tells a completely different story than the dollar weighted return. I'll remind you that the dollar weighted return for this in this scenario was a negative, I think, 4.57. We'll see it in a video, in a slide shortly, but it was definitely a negative 4 point something percent return. So this is telling a completely different story. And so what's going on here? Well, look, the time weighted rate of return is taking into account the actual asset performance between transactions. For instance, look at the time period from April 1st to July 1st, from time 0.25 to time 0.5. That periodic accumulation factor was a 75,000 divided by 55,000, which means the 55,000 accumulated to 75,000 over that 3-month period there. That's a outstanding accumulation. And it happened though right after we took out $50,000, right after there was a withdrawal of $50,000. So it was a bad timing on that withdrawal of $50,000. Now keep in mind that a lot of these times you don't really have a choice on when you're withdrawing money. For instance, this money might be, with respect to say pension plans, this money might be taking money out of the pension trust fund to pay benefits, and you just don't have any option. You have to do it. And so there might not be, it might not be up to you when you want to make the deposits and the withdrawals. It might be set by, for some other reason. But the $50,000 that was taken out of the account at time 0.25 was taken out at a very bad time, because over the next 3 months there was an excellent return on that money. And then the $50,000 that was put back into the account at time 0.5 was put into the account at time 0.5, but the performance in the account from time 0.5 to 0.1 was very poor, because the 125,000 lost money. It accumulated to 96,000 at the end of the year. So the assets did very bad at that time. So assets did bad at the time that you put more money into it, and assets did great at the time that you took money out. If you were able to switch those transactions around, the story would be even better. But the point here is that the dollar weighted rate of return doesn't tell the whole story. In this case, the time-weighted rate of return was pretty good. The performance of the asset manager was actually pretty good at almost a 10% return. So, okay, so let me kind of capture all the information in a slide here. In one slide, let's say that we have the same setup that we have here, and the question was just to determine the asset manager's performance. Well, if you used a dollar weighted rate of return, you're gonna say the asset manager's performance was not that good. There was a negative 4.5% return on assets. However, if you used a time-weighted rate of return, you're going to say, oh, well, the asset manager did pretty well. There's almost a 10% return on assets, or a 9.96% would be what the time-weighted interest rate would be. Okay, so things can tell different stories, and you just have to follow the directions, do whatever they tell you to do, and we'll look at an example next. We'll look at an example that is very similar to what I would expect you to see on an actuarial exam. Okay, I'll see you in the next video.